A sphere of mass m is suspended from a light string. The sphere is pulled aside by horizontal force F of magnitude F equal to Newton. The sphere maintains equilibrium where it makes an angle alpha equal 45 degrees with respect to the vertical. Take a g equal 10 meter per second squared. The first question is to name and represent the forces acting on the sphere, and the second question is to determine by applying the equilibrium condition the tension in the string and the mass of the sphere. The forces acting on the sphere are the horizontal force F, weight of B, W vector, and the tension T vector. Consider B to be a point object. Take B as the origin of the XY system in order to represent all the forces on the particle. Now, the second question is to determine by applying the equilibrium condition the tension in the string. So we start by projecting the forces. We have T vector, Tx and Ty component. Tx, as you can see, T is represented along the string upwards. So we do orthogonal projection on the x-axis for the x component and on the y-axis for the y component. So it's clear here that it's in the negative direction of the in the negative direction of the x-axis. So it should be negative. Negative what? We have alpha is given. So if you can see this F, these are two parallel lines. So this is alpha and this is alpha. And because their corresponding angles of parallel lines are equal, and this is 90. So we can find the angle between the force and the x-axis by writing 90 minus alpha, because if this is 90, then this angle and this angle, the sum of this angle and this angle is 90. So if this is alpha, then this is 90 minus alpha. In this case, it won't matter because it's 45, so this will also be 45, but we're talking in principle. So minus t times cosine 45. Why cosine? Because tx is the adjacent of the considered angle here, formed between the force and the x-axis. So it's minus t cosine 45. Ty is actually this side, because this is a rectangle and opposite sides in a rectangle are equal. So we consider this one to be equal to this one, to ty, then it's opposite to the considered angle. That's why we say it is sine 45, or it could be cosine 45, because they are equal to each other. And then it's 10 radical 2 over 2, which is equal to 5 radical 2 Newton. So here we can write it sine 45, because if we consider this angle, ty is the adjacent to it, and if we consider this angle, ty is the opposite. So in both cases it's 45. So in this case it doesn't matter. It is 10 radical 2 over 2, 5 radical 2 Newton. W is a vertical force, so its x component is 0 and its y component is equal to the magnitude of the force, which is m times g. And F is a horizontal force, so its x component equal to the magnitude of the force, which is 2 Newton, and Fy is 0 Newton. Now applying equilibrium condition, which says that the sum of all the external forces is equal to 0 vector. Projecting along x-axis, we can say now that the sum of all the x components of the external forces is equal to 0. So now adding them up, we have fx plus tx equals 0 Newton. 2n minus t cosine 45 equals 0 Newton. Take t cosine 45 to the other side, becomes t cosine 45 equal to, divide by the coefficient of t, so t equal to divide by cosine 45, it's 2.82 Newton. Now we need to find the mass of the object. In order to find the mass of the object, we need to find the weight, which is a vertical force. So we have to apply now the equilibrium condition along y-axis. As you can see, the sum of all the y components of the external forces is equal to 0. W plus Ty equals 0 Newton. We have W is a downwards force, that's why we write minus, and Ty is an upward one, so it's a plus T sine 45, 0 Newton. So T sine 45 is equal to mg. We have g is the coefficient of m, so we divide both sides by m. So m is 2.82 sine 45 over 10. It's 0.199 kilograms, which is approximately equal to 0.2 kilograms.